The global need for data processing has made data centers to one of the most power-hungry industries in the world. Today's source of power has made it create similar greenhouse gas emissions as the airline industry. At Bulk Infrastructure, we want to create sustainability as a business, and we want to create solutions to this problem. That's why we focus on the two global megatrends, the climate change and digitalization. We want to create infrastructure that can unlock the global renewable giants, the Atlantic Canada and the Nordics, to the data center industry. The environmental impact has been recognized by the industry for many years. However, the lack of infrastructure like fiber optic cables and powered land has been a challenge. We find, however, some of the most environmentally friendly data centers here in cities like Quebec City. That's where the impact is at its minimum. It's clean, it's green, it's sustainable. The best conditions for data centers will be in places where the reliability of power is second to none. That's why you find me here in Quebec City on the Atlantic Canada region. This province has more than 99% of all power produced from renewable energy, and 95% of it is from stable baseload hydropower. The total power generation in the province amounts to more than 200 terawatt hours, and it makes the greenest renewable giant in North America. The abundance of clean power gives the data center industry the most affordable electricity in the world. As cold climate embrace these Atlantic Canada regions, the data center can also utilize cold air as a source of cooling and therefore be more energy efficient than other locations. So if you want to be smart about how we manage global energy resources, we need to enable ways for data processing to happen in these regions. It's clean, it's green, it's sustainable. I'm here in Quebec at the Manicouagan River, and I'm looking up on the Manicouagan. The installation operates 8 of these Francis turbines, each weighing more than 57 tons. These are the installations from old school infrastructure that the future depends on to produce clean, renewable energy. It's clean, it's green, and sustainable. The power grid in the Atlantic Canada is second to none. When we transmit power over long distances, we get power loss in the grid. There's large distances between the provinces in Atlantic Canada, between the hydropower production up north and the industries and the people in the south. The two power giants in the regions, the Hydro-Quebec and Nalcor, has therefore developed a world-class power grid to transmit the power over long distances with minimal power loss. The 760 kV transmission grid in the region is the largest in North America. It is extremely reliable and moves efficiently the renewable energy in the north to the south. It's clean, it's green, it's sustainable. Renewable energy from hydropower and wind has existed for centuries in small scale. But more than 100 years ago, mankind started searching for sources of power that can scale. That brought the first researcher to the Manicouagan River here in Quebec to evaluate the potential for power production already in 1919. The construction of the dam is considered to be an engineering masterpiece, but also it's the world's highest multiple arch and buttress dam. With its 14 buttresses and 13 arches, it mounts to 214 meters high. During construction, it was also the largest workplace in North America with its 12,900 employees. Manicouagan power plant was opened in 1970 with 12 Francis turbines yielding an impressive 2,660 megawatts of capacity. It's now one of the many renewable giants in the Atlantic Canada region that enables affordable, clean, renewable energy today, more than 50 years later. And it will be for generations to come, because it's clean, green, and sustainable. One of the reasons the Atlantic Canada region is so well suited for hydropower production is the wet and cold climate. The rain falls on a massive landscape and does not easily evaporate. Millions of creeks lead the water into large lakes before it falls into rapid running rivers, where power plants harvest the energy towards the ocean. What makes the Manicouagan system so unique is the size of its reservoir. Although it was shaped by man to scale the hydropower system, an asteroid landed here and made the 5th largest crater in the world 214 million years ago. From the sky, you can see a unique round shape of the reservoir, nicknamed the Eye of Quebec. It is now one of the biggest freshwater reservoirs in the world that constantly feeds the hydropower plants in the rivers below. It's clean, it's green, and sustainable. This great river, the Innu called Churchill, the place where current makes clouds. Creating renewable energy for all of us to have sustainable power availability throughout the world. It also makes an impact to the environment as we do that. We can see one of the local impacts it has made to redirect the river into the power station. These are the things we need to consider locally as we develop renewable energy in the future. Although the local environmental impact rerouting this river has made, it is now generating power at the capacity of 5,428 megawatts. It's clean, it's green, it's sustainable. I'm here at the tail race of the Churchill Falls power plant. The tail race is where the outlet of the water from the plant is. The water comes to the inlet. It drops 312 meters through 11 Francis turbines that yields 32 terawatt hours a year. After it's been through the plant, the water comes back into the river. It follows the same route towards the ocean. That's how we create scalable renewable energy. It's clean, it's green, it's sustainable. I'm here at the Lower Churchill River power plant, also called Muskrat Falls. It used to be a waterfall of 15 meters that has now turned out to a reservoir of 34 meters in height. Here they have 5 gates that controls the spill water as it flows down the river. The gates are 30 meters high, and it gives you an idea of the size of the project. Now you can see there's only a fraction of one of the gates open. And if you get an idea of the amount of energy in that water, you can see why this plant harvests the last 35% of the river as it flows towards the ocean. Because it's clean, it's green, and sustainable. Here at the Muskrat Falls power station, we have 4 Kaplan turbines with 206 megawatts each, making a total of 824 megawatts capacity. This will yield 4.5 terawatt hours annually, going forward for more than 100 years. Building a massive construction like this safety is first. Here they've had 51 million man-hours and no major incidents. It is a great achievement for the communities around and for the people that has been involved. We need all of us renewable energy that can scale for the future because it's clean, it's green and sustainable. I'm here at the 10th largest hydropower plant in the world. It harvests energy from the fall of 74 meters, which is 5,428 megawatts. Similar capabilities can be done in the future. They're already ready to produce more of hydropower. We need sustainable digital infrastructure so we can grow as we scale with digital services, because it's clean, green and sustainable. The energy we can harvest from the region of Atlantic Canada is second to none, both on wind and on hydro. But most of all, having a transatlantic cable, the Leif Eriksson subsea cable, built from Norway to Canada, will open up for a great migration for data centers into the regions. The beauty of the cold north is that we can cool down data centers and have them use less power for the production of data. I'm here at the Churchill community at the end of Lake Melville. This is where the transatlantic cable will end. This is where the land cable will start. It's the beginning of a long journey for 1,800 kilometers between Churchill and Goose Bay down to Montreal. It's clean, it's green and sustainable.